Right now, a machine is digging tunnels under Las Vegas faster than any project in U.S. history.
Well, I did say for the longest time that people ought to build tunnels, and then everyone thought I was joking. And then I was like, fine, well, let's just create a company, the Boring Company, to build tunnels.
In just the last few years, it has carved out more tunnel than the rest of the country built over the past 25 years combined. And here's the strange part. Almost no one is inside running it. This is the story of how Elon Musk's companies are quietly rewriting the rules for tunnels, satellites, self-driving cars, and electric trucks, all at the same time. Let's start underground.
The Boring Company is Elon Musk's tunnel building business. Its biggest project right now is the Las Vegas Loop, the largest infrastructure project happening anywhere in the United States. The loop already connects the Las Vegas Convention Center to the city's airport, and it loops around 3 major hotels. For the first time, cameras got a look inside these tunnels while they were being built. Here's why this project moves faster than a normal subway. On a regular train, when you add a new station, every single train has to stop there, even if most riders don't want to get off. The Vegas Loop skips that problem completely. Each car drives straight from point A to point B. Stations sit on side ramps that branch off the main tunnel, so most cars never even slow down. And if the system ever needs more capacity, they just dig another tunnel. But here's where things get interesting. The real breakthrough isn't the tunnel shape, it's how the tunnel gets built in the first place. Normally, digging a tunnel means putting a crew of a dozen people or more deep underground, right next to a giant spinning cutting machine. That's dangerous work, and when your main job becomes keeping people alive, you don't have much energy left over for speed. So Musk set a simple goal: get people out of the tunnel completely.
The Boring Company has been chipping away at that number for years. Early machines needed 12 workers inside the tunnel, then 9. On the newest projects in Las Vegas, Nashville, and Dubai, that number is down to 2. Their next machine, called Prufrock 6, is designed to run with 0 people underground. It will be controlled entirely from the surface.
Here's the wild part. That surface control room doesn't even need to be near the tunnel. Every boring machine the company runs right now is operated from company headquarters in Bastrop, Texas. That includes the machine currently digging a brand new tunnel in Dubai, on the other side of the planet.
It's not just the boring machine that's been automated. The conveyor belts and excavators that clear out dirt and rock now run without drivers too. And one invention stands out. To haul heavy concrete tunnel segments underground, the company uses a modified Tesla Model 3. All the normal car parts are stripped out and replaced with heavy-duty industrial gear. Hauling that much concrete cuts its driving range from around 300 miles down to just 15 or 20. But because it's built on Tesla's self-driving platform, it can be remote-controlled from Texas, just like the boring machine itself. That solves the labor problem. But there's a second bottleneck that matters just as much: speed. A typical tunnel boring machine works in 2 separate phases. First, it digs. The cutting head spins, chews up rock, and sends it out on a conveyor belt. Then it has to stop completely and switch to phase 2, installing concrete wall segments to keep the tunnel from collapsing. Digging and building never happen at the same time. That stop-and-go process is a big reason tunnel projects usually crawl along.
The Boring Company's newest machine, Prufrock 5, is the first to break that pattern. It can dig and build at the same time, which means it can move at least twice as fast as older machines. Right now, it's running test tunnels in Texas before heading to a full-scale project later this year. Underground tunnels aren't the only thing changing fast. Up in orbit, SpaceX just solved a problem that's followed Starlink internet since day one.
Starlink can already beam high-speed internet to some of the most remote places on Earth, but you still needed a stable spot to plug in the receiver. That's a real problem in a war zone, a natural disaster, or the middle of a protest. Situations where reliable power is never guaranteed. SpaceX's answer is a new receiver called the Starlink Mini Dish 2. It's small, square-shaped, and built to use very little power with its own internal battery. It's also designed to work while you're moving, which basically turns it into a grab-and-go hotspot you can carry anywhere.
There is a trade-off. Early tests show speeds between just 1 and 20 megabits per second, nowhere close to Starlink's usual performance. This isn't built for gaming or streaming, it's built to be a lifeline when nothing else works. As SpaceX rolls out its next generation of satellites, launched using the Starship rocket, those speeds are expected to climb.
Speaking of things built to move fast, Tesla just made a major upgrade available to cars that were supposed to be left behind. If you own a Tesla built before 2024, you've probably watched newer models get better self-driving features while yours stayed the same. The reason is hardware. Older cars use a computer called Hardware 3, and there's no way to physically swap it out for the newer Hardware 4 chip. But Tesla appears to have found a software workaround. A new self-driving model called FSD V14 Lite is now in limited testing on older Hardware 3 vehicles. Early reviewers say the entire interface feels more polished, and the driving itself has noticeably improved. Highway driving handles lane changes and passing more smoothly. City streets are handled with more confidence, and the car hesitates less at stop signs. Parking, on the other hand, still needs work.
One team put this update through a serious stress test. 2 people drove more than 4,200 miles from Key West, Florida, all the way to Cape Flattery, Washington, without ever touching the steering wheel, brake, gas, or turn signal. They didn't stop there. They kept going, heading up toward Alaska, all on a car that technically shouldn't have this level of self-driving capability. Tesla's VP of AI software has said this version is likely close to a full public release. And while all of this has been happening on the road and underground, Tesla has also been quietly building out infrastructure for something bigger: electric big rigs. The company just opened its first public charging station built specifically for the Tesla Semi. It sits in Bloomington, California, about an hour east of Los Angeles, right in the middle of one of the busiest freight corridors in the country. That location isn't random. It sits between the ports of Los Angeles and Long Beach and the massive warehouse network further inland, right where freight trucks need to recharge. The new station has 6 charging stalls, each capable of delivering more than a megawatt of power. That's a serious upgrade from Tesla's earlier test site near Ontario Airport, which topped out at 750 kilowatts and isn't even publicly listed anymore.
So what does all of this add up to?
4 different projects: tunnels, satellites, self-driving software, and truck charging. On the surface, they don't look related, but they follow the same pattern. Take a slow, expensive, human-dependent process and strip out the parts that don't need a person involved. That approach has real upside. Tunnels get built faster and cheaper. Internet reaches places that never had it. Older cars get new capabilities without buying a new car. Trucking companies get infrastructure that didn't exist a year ago.
But it raises real questions, too. Fewer humans in the loop means fewer jobs in these industries over time. Remote-controlled machines depend completely on stable software and connectivity, like a facility in Texas controlling a tunnel boring machine in Dubai. And a self-driving car that goes thousands of miles without a single manual input is impressive, but it's not the same as a system proven safe for millions of ordinary drivers. What's clear is that these are no longer separate side projects. They're pieces of the same strategy, playing out across different industries at the same time. If you enjoy learning about the future of AI, robotics, and emerging technology, subscribe to AI 2040 Almanac. We'll keep bringing you the biggest breakthroughs before they become everyday news.